Okay, thank you. So this is a talk in QA for AID Scotland. Just to give a quick introduction to myself. So my name is Helen Sandison. I'm a senior engineer at CENSIS, which is the Innovation Centre for Sensing, Imaging and Internet of Things. My job mainly involves a lot of data analysis and visualization. I'm the technical lead of the Vision Lab here at CENSIS, and we're based here in Glasgow. So what I'm going to talk about today, I'm going to give you a kind of brief introduction to how I got involved in engineering. I'm going to tell you a little bit about how I think programming as a skill is really important and a good one to have. I'm going to tell you why I think engineering as a career might be something that is an interesting one to go into. I'm going to give you some inspiring women engineers and talk a bit about the STEM community in Scotland. Okay, so first, after finishing at school, I did some studies at the University of Glasgow. Initially, I started studying electronic engineering, but fairly quickly I realised that my main interest was actually more towards the physics and maths side. And specifically, I realised that if I studied physics, I could also study astronomy, which is something that had interested me since I was a young child. So I moved over to studying physics and astronomy, and I graduated from Glasgow in 2001. So after graduating, I got my first job as a graduate engineer down in Bedford, just outside London. I worked for a company called DERA, which is the Defence Evaluation and Research Agency. That company is now called Kinetic, and I worked there in the Department of Flight Simulation. I worked specifically on developing software for the synthetic environment, which is this kind of area that you see here. You have a plane flying through land, through towns, etc. Synthetic environment is what we created to allow the plane to fly. So I'm just going to make this better. After a year down in Bedford, I then moved back up to Edinburgh and got a job in a company called Celex Sensors and Airborne Systems, now known as Leonardo, and that was a job as a systems engineer, working on radar technology development. I've got a couple of examples here you can see on the slide. So the top slide, you can see the nose cone is lifted and there's kind of a big white rectangle, which is where the radar is fitted. There's another example of the radar down at the bottom, which is a Seaspray 7000E radar. And these are electronic radars, mainly for maritime surveillance. So they're used for Coast Guard and border agencies and so on. My job involved developing radar beam control, such as radar beam shape and direction, where you point the beam, for example. I was also involved quite heavily in the radar test and calibration of all the different elements. And I did some software development there, mainly in C and in MATLAB. And then after a few years at Celex, I then moved on to a company also based in Edinburgh called ST Microelectronics. So it's a bit of a change in direction, this time involved in semiconductor chips, similar to the one you see in the top left. So my job there was as an applications engineer, and we worked on time-of-flight technology for proximity and ambient light sensing. So the small chip you see there at the top is actually very small. You can pretty much balance it on the tip of your finger. And in the image below, where it actually goes is in that laser autofocus. Hopefully you can see that okay on the picture. So it's a very small chip. And it's used for autofocusing for the camera on the mobile phone. My job there involved various types of data analysis, testing devices, and dealing with customer applications and customer technical support. About 6 years ago now, I moved to CENSIS, which is where I'm working just now. My job is a senior engineer with data analysis, visualization, and imaging. Here at CENSIS, we work on really a very wide range of projects. Just a few highlights I've worked on recently: some gas sensing project, marine engine analysis, facial recognition, and image analysis for manufacturing. We deal with innovation in technology, and we collaborate a lot with universities and companies throughout Scotland and beyond. And software development in this job can involve a range, including MATLAB, R, which is good for data analysis, Python, and JavaScript. So what ties, I think, all these jobs together kind of fundamentally is programming. I want to talk a bit about why I think programming skills are very useful for engineering. So you can write computer code to solve many different problems or perform tasks. These can be a very wide range of things, including calculations and graphs. You can create web pages, you can enhance photos, images, or video. You can analyze and present results. You can do many, many more things as well. But what I think is key to programming skill is the computational thinking that you develop, which involves breaking a problem into smaller and smaller chunks. You apply some logic to these problems, you build them back together again to provide a solution. So programming is, of course, very technical and analytical, but it can be very creative at the same time. So programming languages are many and varied. I've put up a selection here, some of which you're probably aware of. So Python is very, very versatile, and it's a relatively easy language to learn. It's a good first language to learn, I would say. It's used for web applications, game development. It's very good for data science and visualization. C++, a bit more tricky language to learn, but again, it's very powerful, very fast. It's good for many different things, including games, apps, databases, embedded systems, and scientific computing. JavaScript is one of the web development languages, very good for web apps, servers, and mobile applications. Java, again, very good for apps and games. Again, it's very powerful, very secure, very versatile language. C# is another language which you may have heard of. It's embedded systems, Internet of Things and real-time systems, and system programming. Of course, there are many, many other languages to learn, each of which are developed for specific tasks. But again, just going back to what I said about computational thinking and what programming I think really teaches you, is how to really break down a problem into small tasks. You can then start to identify similarities or patterns within the problem, and you can identify kind of main principles or rules, filter out any unnecessary information, and that gives you the steps to develop algorithms which you need to solve the problem. So why do I think you might want to choose technology or engineering as a career? So first of all, if you enjoy learning, you really never stop learning in engineering. Same with problem solving, you're always looking at problems, trying to solve some issues, trying to fix things, trying to create things. It can be very challenging, but often, usually in a good way. It's very interesting as well. Again, I've told you some of the variety of tasks and projects that I've been involved in. There are many more, of course. Creative, I didn't mean for that word to be written in smaller letters, it just came out that way, but it can be very creative work as well. Innovation, of course, you're always creating new things, whether it's new programs, designing new devices. It's always something new to create. You often collaborate with different people, different companies, and of course, the job is very versatile. There's really a huge range of opportunities in engineering. In fact, some of them are written here. This covers, again, just a few of the many different opportunities you might find in engineering. If you look down the sectors, you have everything from aerospace to civil engineering, computer engineering to defence, energy to the environment, manufacturing, and so on. And there's so many different roles that you can find in engineering, some of which are written there. I want to talk a bit about some inspiring women engineers. This is quite a famous photograph, and this is a photograph of Margaret Hamilton, who was, or I think still is, a US computer scientist. She was director of software engineering at Massachusetts Institute of Technology. She was part of the team that developed the onboard flight software for the NASA Apollo programming. And that image shows the program from the Apollo guidance computer. So in there is the directions to fly the rocket to the moon and back. This is a more recent picture. I think it's possibly still a famous one. You may have seen it before. This is Katie Bouman, also a US engineer and scientist who works in computer imagery. She led the development of an algorithm for imaging black holes, and had the first direct image of a black hole in April of last year. There's a nice TEDx talk, how to take a picture of a black hole, which talks about some of the techniques that she developed that brought that picture there. Dr. Anne-Marie Imafidon is a UK computer scientist and entrepreneur. She is the youngest girl ever to pass her A-level computing at the age of 11. 20 years old, she got her master's degree in maths and computer science at Oxford. After a career working at various institutions such as Goldman Sachs, Hewlett-Packard, and Deutsche Bank, she then went on to co-found STEMET, which of course is inspiring and promoting the next generation of young women in STEM sectors. So engineering and technology here in Scotland. So working here at CENSIS, we work across a whole range of sensing, imaging, and Internet of Things technologies. We collaborate with universities and companies throughout Scotland and beyond. So we're very lucky we get a wide view of companies' research and development activities. So I just wanted to highlight some areas of technology and engineering going on in Scotland now. Here are some I thought were very interesting. So artificial intelligence and data science. Edinburgh and the Data Lab has some really pioneering work and research going on there. Scotland has a big space industry, which designs, match for manufacturers, tests, operates satellites. This is a growing industry. Also in advanced manufacturing, more and more robots and virtual reality, augmented reality technologies are coming into the manufacturing process. Health technologies, there's an innovation centre for precision medicine here in Scotland. There's also a consortium that developed brain imaging research, which is very world pioneering research. Edinburgh also has a robotics lab between Heriot Watt and Edinburgh University. And there's a big renewable energy and also subsea technology sectors here in Scotland. That's very much some highlights. That there's a lot going on elsewhere, of course, as well. Of course, groups, organisations and community is very important, and I wanted to, sorry, just meeting a few people here. I just wanted to highlight some of the organisations that may be interesting. Coder Dojo, Ladies of Code is a meetup based in Glasgow. Code First Girls, another group. STEMET, I mentioned already. If you've ever been to any of the STEMET events, I've been lucky to go to a couple and help out there. They're great fun and really interesting, so very much recommend. Girl Geek Scotland, and of course Data Scotland. I think right now is a good time to say thanks to the organisers for arranging this event. I think it's really important to bring people together. And I think that's the main things I wanted to say today. Thank you very much for joining. If anyone has any questions, then I'll be happy to try and answer them. Thanks.